Welcome back, focused learners. Okay, so today we've got a truly fascinating explainer lined up for you. We're going to explore the intricate, deeply overlapping systems that make our planet uniquely habitable in what is otherwise a pretty incredibly hostile universe. I mean, when you look out into the cosmos, Earth is a profound anomaly, right? And understanding why, well, that requires us to look past the surface and truly grasp the foundations of the world around us. We're going to uncover how our planet functions, not just as some static rock floating in space, but as a dynamic, living machine. Which leads us to the ultimate question. Why is Earth the only planet in our solar system with life? It's a huge mystery, isn't it? Well, the answer doesn't just lie in a single lucky feature. It's not merely about our distance from the sun or, having a rocky surface. Instead, the answer lies in an active, highly dynamic collaboration. Earth essentially functions as a giant interlocking engine made up of four deeply connected physical systems, and they operate in such perfect, mathematically precise harmony that if you altered even one of them just a tiny bit, the entire planetary system would collapse and life would simply cease to exist.
Okay, let's dive into this. Here's our roadmap for today's explainer. First, we'll meet our unique planet as a whole. Then, we're going to build our understanding right from the ground up, examining the lithosphere, wading into the hydrosphere, looking up at the atmosphere, and finally combining them all together in the biosphere.
All right, Section 1. Meet our unique planet, the big picture. Before we start breaking things apart, we really need to look at the big picture and establish the reality of Earth's distinct but highly overlapping environments. You've got the solid land, the deep water, and a thin layer of gas up above. And together, they create the absolute perfect cocktail to support living organisms. But the really important thing to understand here, why this matters, is that these domains absolutely cannot exist in isolation. They are constantly exchanging energy, matter, and heat. Think about it. The water shapes the land redirects the air, and the air carries the water. Literally, every plant, animal, and human relies entirely on this continuous interplay.
Moving on to Section 2, Lithosphere, the solid foundation.
Let's examine the literal ground beneath our feet. So the word lithosphere actually comes from the Greek word lithos, which means rocky. Now, if you think of the Earth as an apple, the crust, which is the only part of the planet humanity has ever actually interacted with or drilled into, is literally as thin as the apple's skin. Beneath that skin is the mantle, and deeper still, the outer and inner core. So the lithosphere itself is made up of that paper-thin outermost crust along with just the very upper, rigid part of the mantle. And this incredibly thin, solid foundation provides the structural integrity for our entire surface. It's where we get absolutely all of our natural resources, from the soil that grows our crops to the metals and minerals we use to build our cities.
But here's the thing, the lithosphere isn't just uniform everywhere, and that variation is absolutely crucial. We have the continental lithosphere, which forms the massive, thick land masses of our 7 continents. And then we have the oceanic lithosphere. Now, the oceanic crust is actually much thinner, but it's significantly denser and heavier than the continental crust. Because it's thinner and denser, it naturally sinks lower than the continents, forming these massive global basins. And this architectural difference perfectly dictates exactly where our oceans pool. Without this duality in the Earth's crust, the water would just spread evenly across the entire globe, and we wouldn't have the dry land that we call home.
Section 3. The hydrosphere, the water world. And that brings us to the domain of water, the vital ingredient that earns Earth its famous nickname, the blue planet. Nearly 3/4 of our planet, about 75%, is covered in water. That sheer surface volume includes everything from deep oceans to glaciers, underground reserves, and even atmospheric water vapor. But here's a truly fascinating twist for you. Because it's mostly just a surface layer, if you somehow gathered all of Earth's water, both fresh and salty, into a single floating drop, that sphere would only be about 860 miles across. That is a tiny, tiny fraction of the Earth's total physical volume. Yet, this relatively small, precious amount of water is the great enabler of literally all biology.
Furthermore, this domain isn't static at all. It is incredibly dynamic. You can kind of think of the water cycle as the Earth's global circulatory system. It doesn't just move water around, it actually distributes the sun's energy and heat across the globe. So, the sun's heat causes water to turn into vapor through evaporation, it cools and forms clouds in the sky through condensation. And then, when those clouds get a bit too heavy, it falls right back down through precipitation. It's this endless, beautiful engine that keeps the planet's climate regulated, literally preventing the equator from boiling over and the poles from freezing completely solid.
Which leads us to Section 4, Atmosphere, our invisible blanket.
So, the atmosphere is this crucial invisible blanket that absorbs the sun's heat and keeps our planet's temperatures from swinging wildly between night and day. But even more importantly, it contains a highly delicate Goldilocks recipe of gases. And this brilliantly illustrates just how perfectly balanced everything is. The air around us is mostly nitrogen at 78%, which keeps things chemically stable, and oxygen at exactly 21%. Now, why does that exact oxygen percentage matter so much? Well, if oxygen levels were just a few percent higher, the atmosphere would be so combustible that fires would literally burn out of control across the entire planet. But if it were any lower, complex life as we know it would just suffocate. And that remaining 1%, that holds trace gases like carbon dioxide, which plants desperately rely on to manufacture their food.
And this blanket doesn't just stop abruptly, it extends several kilometers outward. Starting from the troposphere near the surface, which is where we live and where all of our weather happens, you travel outward through the stratosphere, the mesosphere, and the thermosphere. But there isn't actually a hard-defined border where the Earth ends and space begins. Instead, the atmosphere just gradually fades out into the vacuum of space, ultimately thinning away in the exosphere, which is roughly 10,000 kilometers away. It is quite literally our planetary shield against the harsh radiation of the cosmos. Finally, Section 5. Biosphere, the zone of life.
So the crucial point is that the biosphere isn't really a separate physical location at all. It is the magical, highly improbable overlap where the rock, water, and air actually meet and interact. I mean, just think about this for a second. Out of the entire 6,300-kilometer radius of the Earth, life only exists in a fragile vertical band that's about 18 kilometers thick. It stretches from just about 8 kilometers deep in the darkest ocean trenches to about 10 kilometers up into the thin atmosphere. It is an astonishingly narrow 18-kilometer slice of habitability suspended in the infinite vastness of space. Every single living thing we know of exists right within this tiny sliver.
If we break down this biosphere, we see two fundamental, deeply interconnected parts. Biotic components are all the living organisms. Abiotic components, on the other hand, are the non-living elements, so the water, soil, rocks, and air. To really understand their relationship, it helps to think of a theater. The abiotic elements are the stage, the lighting, and the oxygen in the room. The biotic elements, whether that's a deer in the forest, a whale in the ocean, or you watching this explainer right now, are the actors. Every biotic element is completely tethered to the abiotic. The actors absolutely cannot perform, and indeed cannot survive, without the stage.
Just look at how seamlessly life navigates these spaces. Take a dolphin, for example, a biotic organism. It launches out of the hydrosphere. It relies on the physics of gravity dictated by the lithosphere, and it takes a crucial breath of oxygen from the atmosphere before diving right back down into the ocean. It's a perfect demonstration of how life interacts with multiple domains of the Earth simultaneously. Life doesn't just casually exist in these spheres. It uses them, traverses them, and constantly bridges the gaps between them.
We've seen how perfectly balanced and interconnected the solid Earth, the waters, the air, and life truly are. But remember, pulling one single thread affects the entire tapestry. So as you go about your day, I want you to ask yourself, how do our daily human actions ripple through these interconnected domains? When we alter the air or the water, we are fundamentally altering the stage upon which all life depends. It's a profound responsibility that we all share within this incredibly rare 18-kilometer slice of the universe. Well, thanks for joining me for this explainer, Focused Learners. Keep exploring, keep questioning, and I'll see you next time.